Greetings, students, and welcome back. We'll be reviewing the Introduction to Statistics, going over statistical questions, and also histograms on how to display data sets as graphical representations. There will be a homework assignment at the end of this video, which can be found still on eCampus in Unit 8. The homework for tonight is the homework for 9.1. Let us begin with the Introduction to Statistics Learning Goals. 6-11, develop an understanding of statistical variability, and also 6-12, summarize and describe data distributions. Our objective for this unit is to be able to pose questions that can be answered by data, determine a plan of collecting data, summarizing the data with graphs and numerical summaries, and the question posed using the data and summaries. Statistics is the science of collecting, organizing, analyzing, and interpreting data. Let's go over first what a statistical question represents. In this scenario, Jerome is a 6th grade student at Roosevelt Middle School and a huge baseball fan. He loves to collect baseball cards. He has cards of current players and of players from past baseball seasons. With his teacher's permission, Jerome brought his baseball card collection to school. Each card has a picture of a current or past Major League Baseball player, along with information about that player. If you were in Jerome's class, what are some of the questions you have for Jerome? The questions you may have for him might regard the statistics of the baseball players, such as their home run score, maybe their speed, maybe their strikeouts, things like that. Do you believe each baseball player will have the same stats? Or will there be variability? Let's take a look and investigate what kind of questions we may ask that might have different answers. The directions for the next 5 questions are as follows. For each of the following, determine whether or not a question is a statistical question, and give a reason for your answer. Take a look at questions number 1 through 5. 1. Who is my favorite movie star? 2. What are the favorite colors of 6th graders in my school? 3. How many years have students in my school's band played an instrument? 4. What is the favorite subject of 6th graders at my school? And 5. How many brothers and sisters does my best friend have? I'd like to take a few moments for you guys to answer these questions the best possible. Pause this video now and take some time to answer. We will resume when you unpause. Welcome back. Did everybody answer question number 1 in the same manner? Do you believe that you and your classmates would answer question number 1 in the same fashion? Is your movie star favorite the same as mine, Arnold Schwarzenegger? How about question 2? Do you know the favorite color of all 6th grade students at the school? Or number 3, do you believe that all the students in your school's band have played an instrument? 4, do you think every student 6th grade has a favorite math subject? And 5, do you believe every student has the same number of brothers, sisters, and their best friends as well? The questions may have one answer or more than one answer. That dictates whether a question is statistical or not. Let's take a look and classify which questions are not statistical. Question number 1, how old am I? Question 2, what's my favorite color? Question 3, how old is the principal at our school? If you ask another student, how old am I? How old is Mr. Wong? Do you believe that there will be many different answers? I'm not saying that students can't try and guess my age, but how many correct answers will there be? What if I ask the students, what's my favorite color? Do you think everybody would take a right guess? Guess the same color? Or are there multiple favorite colors? And question 3, will there be different answers for the age of our principal? I mean, when we guess, of course there might be. However, how many of those guesses are to be right? These questions are not statistical because they only have one answer. Very similarly, if I ask what the favorite movie star is, it might be a different answer. And some of these might require some data collection, such as asking the students at our school what their favorite subject is. I mean, we know the answer is math, but I digress. Let's move on. And now that you know what differentiates statistical questions from non-statistical questions, I want you to take some time now to write a statistical question that can be answered by collecting data from students in our class. It has to be a question that will offer up many different answers to have variability. Take a few moments right now and pause the video to write up your own question that you can leave in the comments down below once the video concludes. Pause the video now. Welcome back. Did you come up with your own statistical question that you can leave in the comments? We can have a bunch of the viewers just like and dislike. Maybe they're best ones that are statistical, not statistical. Let's continue. There are two kinds of data, two types. One is numerical and one's categorical. And as you may suggest, just by the name you can figure out which ones involve numbers. I want you to identify each of the following sets as either numerical or categorical. Number one, the heights of 26th graders. When asked for height of 26th graders, will the answers be numerical or categorical? Let's change it and make it easier. What's your height? Would you actually give us a numerical answer? Or would you just tell me that you're tall or you're short? Question number one, yes, is numerical. Let's continue. Question two, the favorite ice cream flavor of each of the 10th sixth graders. Numerical or categorical? Think about the answer they would respond with. What is your favorite flavor of ice cream? Do you think a student might say 12? Oh, my favorite flavor is 37. No. Of course, the answers will be responded as categorical. Look at question 3. Hours of sleep on a school night for each of the 36 graders that I ask. Hours of sleep? How do we measure hours? With colors? No. With numbers, silly. Number 3 also is numerical. Types of beverages drunk at lunch for each of the 15 sixth graders asked. That would be categorical. Eye color of each of the 36 graders, categorical. And number 6, the number of pencils in a desk of each of the 15 sixth graders. Number of pencils would mean numerical. Take a moment to review the answers from 1, 2, 3, 4, and 5, 6, and differentiate the difference and similarities between numerical and categorical. If you recall the type of question you might have written that was statistical, let's consider that question you just wrote, the one that you leave down in the comments. Would that question that you wrote, that is statistical, is it numerical or categorical when you collect your data? Think about it. Is your statistical question going to create numerical data or categorical data, and why? If you ask the students, well, perhaps how many songs they have in their iPhone or their Android phone, that'll be numerical data. If you ask a question that might require no numbers but a verbal response that might differ, that would be categorical. A majority of our lesson will involve dealing with numerical data. Let's take a look at an example and find a way to display all the values in a data set from a scenario to represent a picture that we can easily see and easily describe. Displaying a data distribution as a dot plot. Example 1, heart rate. Mia, a 6th grader at Roosevelt Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it would compare to the other students. Mia was interested in investigating the statistical question, what are the heart rates of students in my 6th grade class? Heart rates are expressed as beats per minute or BPM. Mia knew her resting heart rate was 80 beats per minute. She asked her teacher if she can collect the heart rates of the other students in her class. With the teacher's help, the other 6th graders in her class found that their heart rates and reported them to Mia. The following numbers are the resting heart rates in beats per minute for the 22 other students in Mia's class. They read 89, 87, 85, 84, 90, 79, 83, 85, 86, 88, 84, 81, 88, 85, 83, 83, 86, 82, 83, 86, 82, and 84. How can we organize this data into a meaningful display or model? Let's have a look. The first step in creating a dot plot is to create a number line that contains all the available data values listed in this set. You can take a look at the values that were listed for the heartbeats per minute. Our lowest value is 79, while our highest is 90. That means our number line must include all those values, even values that are not stated in that list. For example, the heartbeats per minute of 80 is not one of the recorded values of the students in the class. However, we must include the number 80 in our number line. One good thing that I like to do is always have one number smaller and one number larger than the least and greatest values. Since 79 and 90 are on the table here, let's start a number line with 78 and go up to 91. As stated before, there are 22 other students in the class. This means we should have 22 dots on our dot plot, one dot representing each value in the number set. We'll start off by going down the list with 89 and placing a dot above the 89 interval on the number line. Our next number is 87, so we'll put a dot above 87 and continue going down the list with 85, 84, 90, 79, 83, 85, 86, 88, 88, 85, 83, 83, 86, 82, 83, 86, 82, and 84. Let's take a look at the questions that are stated below that we can help describe this data set. Question 1. What could you tell me about the heart rates of the 6th graders? Very similarly, asking about a certain average. Based on the picture below, what do you think the most common heart rate is for 6th graders? Would you say it's anywhere between 82 and 86, where the chunk is? How about 2? Where do the heart rates tend to center? And that'll be around that same part right there. And why did you choose that number? Question 3. How much spread do you see in the heart rates? Well, the spread is from 79 to 90 beats per minute. Also, we can use some academic vocabulary to describe the dot plot. We have a peak at 83, a peak being the highest, and we have a cluster from 81 to 90. Or more importantly, a more compacted cluster from 82 to 86. Now there are no outliers, meaning numbers that are way out there or different from the numbers in the set. 79 is close enough to 81, and even though there is a gap between these two values, we wouldn't call that an outlier. However, if there was a student who recorded a heartbeats per minute rate of, let's say, 50, which goes far beyond the left of the number line, or let's say 120, those values of 50 and 120 will be way different than the rest of the data. We would call this an outlier. We can also use the dot plot to answer some of the questions that will follow to describe the data. Question 1. What was the heart rate for the student with the lowest heart rate? Instead of looking at the data set from a list and trying to find the lowest number, all our values are clearly organized in this dot plot. The answer to question number 1, quite simple. What about question 2? What was the heart rate for the students with the highest heart rate? 3. How many students had a heart rate greater than 86 beats per minute? 4. What fraction of the students had a heart rate less than 82 beats per minute? 5. What heart rate occurred the most? 6. What heart rate describes the center of the data? Question 7. Some students had heart rates that were unusual in that they were quite a bit higher or quite a bit lower than most of the students' heart rates. What heart rate would you consider normal? At this time, please answer questions 1 through 7 from the dot plot above. Pause the video now and resume once completed. Hi kids, welcome back. The answer for question number 1 for the lowest heart rate would be 79. Question 2. What was the heart rate for the students with the highest heart rate? That'd be 90 beats per minute. Question 3. How many students had a heart rate greater than 86 beats per minute? Let's count all the heartbeats greater than 86. We have 1, 2, 3, 4, 5. The correct response for number 3 is 5 students. 4. What fraction of the students had a heart rate less than 82? Well, let's calculate. We have 1, 2, 3, and 4 students out of 22 with heart rates less than 82. The correct response would be 4 20-seconds, or 2 11ths. 5. What heart rate occurred the most? We can see that the 83 beats per minute had the most number of responses with 4 students with that heart rate. The answer number 5 is 83 beats per minute. 6. What heart rate describes the center of the data? I would conclude, based on the distribution, that the center of the data would be anywhere from maybe 82 to 86, or you can find the middle with 11 students and 11 students on either side of the distribution. Let's count the values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There will be 11 students here to the left of this halfway point, 84.5, and 11 students above 84.5. You could describe the center of the data as 84 to 85, or 84.5. 7. Some students had heart rates that were unusual in that they were quite a bit higher or quite a bit lower than most other students' heart rates. What heart rate would you consider normal? I would say, based on the data, anything with maybe 2 responses up to 3 before I see a large decline. I'd say a normal heart rate for 6th grade students resting would be between 82 and 86. What do you think? Would a correct or appropriate response be that a normal heart rate is in the 90s based on this? I mean, we do have one of them that's 90. Or how about the 70s? Would you conclude that a normal heart rate for resting 6th grade students would be in the 80s? You'd be correct. Let's continue and analyze 3 more questions with additional data. If Mia's teacher asks what the typical heart rate is for 6th graders in class, what would you tell Mia's teacher? Would it be the same response as question number 7? In the 80s? Question 9. Remember, Mia's heart rate was 80 beats per minute. Add a dot from Mia's heart rate to the dot plot in example 1. How does Mia's heart rate compare with the heart rates of the other students in the class? Would you say she's below average or above average? I'd say she's well within the norm based on the results we see from this experiment, but I'd say that she's below average, knowing that the average would be between 84 and 85. There are some occasions where the number of responses is either too numerous or the values differ so greatly that it would not create a clear picture such as the one we have here for this dot plot. We have peaks, gaps, and we have an overall understanding about where the center of data is. However, some data collection will actually have numbers that are too far apart or too few in the responses that there might only be a single dot above each number on a number line. We have to create something else to represent that data. Creating histograms. In this example, we'll see how to create a histogram from the data values from this given experiment. The girls and boys basketball teams at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell baseball caps with the school logo on the front to family members and other interested fans. To obtain the correct cap size, students had to measure the head circumference, the distance around the head, of the adults who wanted to order a cap. The following data set represents the head circumference in millimeters of the adults. Please look at the numbers listed. The caps come in sizes extra small, small, medium, large, extra large, and extra large. Each cap size covers an interval of head circumferences. The cap manufacturer gave the students a table that shows the interval of head circumferences for each cap size. The interval 510 through less than 530 represents head circumferences from 510 millimeters to 530 millimeters, not including 530 millimeters, indicated by the inequality less than. Let's take a look at the other cap sizes. Extra smalls, 510 to less than 530. Smalls are 530 to less than 550. Mediums are from 550 to less than 570. Large is 570 to less than 590. Extra large is 590 to 610. And extra large is from 610, including it, to less than 630. If you have a head circumference of 630 or larger, the manufacturer does not make a cap size that suits your needs. Our first goal in creating a histogram is tallying up the values that fit between each interval. Luckily for us, the dataset includes all the numbers listed in order. Let's calculate how many tallies would include numbers in the 510 to less than 530 range. 1, 2, looks like only 2 values. From 530 to less than 550, we have 1, 2, 3, 4, 5, 6, 7, 8. In our median values, from 550 to less than 570, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. From 570 to less than 590, 1, 2, 3, 4, 5, 6, 7, 8, 9 values. And finally, the last two categories between 590 to less than 510, 1, 2, 3, 4, leaving our last two in our extra large 510 to less than 630. Count the tallies and put that as your frequency. 2, 8, 15, 9, 4, and 2. We use these frequencies to create our histogram. Let's take a look. First, we have to create a graph, very similar to a bar graph. However, bar graphs actually have intervals that are separated. Since our sizes go straight from one value to the next, such as extra small from 510 to less than 530, the immediate number right after this less than 530 is in fact 530, and it continues on from size to size. Let's start by having those correct intervals and the frequencies that include up to 15 on the y-axis. From here, we can use our frequency numbers to create bars of the appropriate height, making sure again that all values within the intervals do continue and are touching one another. In our first one, we have extra small with a frequency of 2. Small has an equal frequency of 8. Medium with 15 frequency. Large, 9. Extra large, 4. And extra large, 2. This is how a histogram is created. As previously discussed, we have a peak with our medium-sized head circumferences between 550 and less than 570. That is pretty much evenly distributed, meaning that very few have head sizes with extra small and head sizes of extra large. We can see that the distribution is even, and we can determine that our average will be a head size of medium. If we are provided with not a data set and instead provided a histogram, we can use the visual cues we see from the histogram to answer some of the questions. Let's investigate. This following histogram summarizes the age of actresses whose performances have won in the Best Leading Actress category at the annual Academy Awards, the Oscars. We can see that our frequency goes up to maybe 35, and our age is in years, with intervals going from 16 to less than 24, meaning that each interval has about 7 or 8 values. And then from 24 to 32, 32 to 40, 40 to 80, 48, 48 to 56, 56 to 64, and a large gap in our 64 to 72, and it continues. Answering these questions, go ahead and write the letters A, B, C, D, and E into your notebooks and answer these questions. Which age interval contains the most actresses? How many actresses are represented in that interval? Describe the shape of the histogram. What does the histogram tell you about the ages of actresses who won the Oscar for Best Actress? Which interval describes the center of the ages of the actresses? And E, an age of 72 would be included in which interval? Pause the video now to answer these 5 questions and resume the video once you've finished. Welcome back. So how'd you do? Let's go over some of the answers and discuss. A. Which interval contains the most actresses? Similarly to the head circumference, which one of these intervals has the highest peak? That's correct. It'd be the 24 to 32 age group. And how many actresses are represented in the interval? Let's probably estimate it to be about 34 actresses. B. Describe the shape of the histogram. I'd say it's a little bit, uneven, not symmetrical. C. What does the histogram tell you about the ages of actresses who won the Oscar for Best Actress? Based on the data available to us, we can clearly see that a majority of the actresses that won in this category are between the ages of 24 and 40 or 24 and 48. Which interval describes the center of the ages of the actresses? I would likely assume that it's anywhere between the 24 to 40 age group. And an age of 72 would be included in which interval? I would assume that it'd be included from the 72 to the 79, because the first leading number always begins, such as the previous example, but it's to be less than 80. Take a few moments to review those answers and rewind if necessary. This concludes the video. The homework assignment can be found on eCampus. 9.1, pages 394 to 395, problems 16, 17, 22, 24, and 28. You may submit your homework via picture photo and email it directly to me, or write your responses into the email when you send the correspondence. However, a printed copy of the homework is not necessary, and photo images of your notebook with work could be used instead. I hope to hear from you soon, and hope this video finds you well. Make sure to hit that subscribe button and smash that like, and we will do a 100 subscriber giveaway for maybe some treasure box prizes. See you in the next video.